Today we are going to discuss differential equations. In this chapter we are going to discuss the concepts of exercise 9.4 and question numbers 1, 2 and 3. All of you watch this carefully, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Right. See the first point. In this exercise, we are going to discuss methods of solving first order, first degree differential equations. In the exercise 9.1, you have learnt how to find order of a differential equation and degree of a differential equation. And in the second exercise, you have learnt general solution and a particular solution of a differential equation, and you have verified whether the given function is a solution of the differential equation or not. I hope you have learned well, you have practiced well. Now in this exercise we are going to discuss methods of solving first order, first degree differential equations. Methods of solving first order, first degree differential equations. Okay, my children, right. See this point. There are different methods of solving first order, first degree differential equation. In this exercise, we are going to discuss the first method, first and foremost method. First and foremost method of solving first order, first degree differential equation. So in this section, means in this exercise, we shall discuss three methods of solving first order, first degree differential equations. You have to learn these three methods of solving first order, first degree differential equation, out of which the first and foremost method is separating the variables. That is also called variable separable method, separating the variables. Now let us discuss how to solve a first order, first degree differential equation by separating the variables method. See here, differential equations with variables separable. This method is called differential equations with variables separable, in which case we use this method. To solve any differential equation, we check this method, first and foremost method, whether this given differential equation can be solved with variable separable method. See here this point. A first order, first degree differential equation is of the form dy by dx is equal to f of x comma y. Any first order, first degree differential equation will be in the form of dy by dx is equal to f of x comma y. F of x comma y denotes a function in the variables x and y. Okay, my children, this is called the first order, first degree differential equation form. Now, how to solve it? By using separating the variables. Listen this method carefully, my children. If f of x comma y can be expressed as a product of g of x into h of y, where g of x is a function of x and h of y is a function of y. Then the differential equation 1 is said to be of variables separable. The given differential equation is said to be variables separable. So in this type of differential equations, if this function f of x comma y can be written as a product of two functions, one function should be in the variable x and another function should be in the variable y, then the differential equation is said to be of variable separable type. Then the differential equation 1 has the form dy by dx is equal to h of y into g of x. Yes or no? Because f of x comma y, this function can be written as a product of two functions, namely one function is in variable y and another function is in the variable x. Okay, my children, right? Listen these steps, my dear children, carefully. If h of y is not equal to 0, separating the variables in the equation 2. Now the equation 2 can be written as 1 by h of y dy is equal to g of x into dx. Just like a number, actually dy by dx is a notation. We cannot treat it as a fraction, numerator by denominator. On the whole, it is a notation, dy by dx. We cannot consider it is a numerator in dy, denominator dx. But for convenient, Leibniz, the mathematician Leibniz, said this notation can be treated as a fraction. The numerator is dy and the denominator is dx. For more calculations, he said that this notation can be treated as a fraction in the number system, as we treat the rational number, numerator and denominator. Here also, in this notation, numerator is dy and the denominator is dx. So we are rewriting this equation as we are transposing h of y to the LHS. So 1 by h of y into dy is equal to g of x into, we are transposing dx, denominator is dx, we are transposing dx to RHS. Then we get 1 by h of y dy is equal to g of x dx. This is important step, my children. In the variables separable method, we have to write the entire function in y into dy is equal to the entire function in x, the entire function in the variable x into dx. This equation is very important in this variables separable method. If you can write the given differential equation in this form, then it is easy to solve the differential equation. Okay, my children, right? So integrating the equation 2. So here we got equation 2. After separating the variables, we got equation 3. In this equation 3, we are integrating on both sides. Integrating both sides of the equation 3, we get integral 1 by h of y dy is equal to integral g of x dx. Understood this question, my children? The first step is we have to write the given function as a product of two functions like this. the given first order first degree differential equation, we have to write the given function as product of two functions. One function is in the variable y and another function is in the variable x. That is the first step. Remember, this is first step. And second step, we have to separate the variables. Second step, separating the variables means we have to write all the function in the variable y into dy is equal to the entire function in the variable x into dx. This is the second step. And the third step, we have to take integration on both sides. So you know here how to evaluate integral of a given function. You have already learnt different methods in the chapter 7 integrals chapter. You have learnt different methods, several methods you have learned. By an appropriate method, you have to evaluate integrals of these functions. Okay, my children, right? Thus, equation 4 provides the solutions of given differential equation in the form of, let us consider, integral of this function is capital letter h of y, and the integral of this function in RHS capital letter g of x. They are the solutions, they are the integrations of the functions in LHS as well as in RHS. And at last step, you know, we add constant of integration. We have found integral of this function in LHS, then we got h of y. Similarly, we evaluated integral of this function in RHS also. We got some function in x in LHS, RHS. And final step, we add constant of integration. This is nothing but, this is the required solution of the given differential equation, which is called solution of the differential equation. Here h of y and g of x are the antiderivatives, means integrals. H of y and g of x are the antiderivatives of 1 by h of y and g of x respectively. Here h of y denotes integral of 1 by h of y dy, and g of x denotes integral of g of x dx. And finally, capital letter C denotes constant of integration. So these are the steps to be followed to solve a first order first degree differential equation by using variables separable method. Okay, my children, remember these steps. First step, you have to write the given function as a product of two functions, namely h of y into g of x, like this. This is the first step. And the second step, we have to separate the variables. Separate the variables means the entire function in y into dy is equal to the entire function in x into dx. This is the second step. And the third step, on both sides we have to take integrals. Then finally you get some answers in LHS as well as in RHS. And finally we add constant of integration. It is nothing but the solution of the given differential equation. Understood these steps, my children? Understood these three steps? Understood these three steps? Yes. Remember these three steps in solving a differential equation of first order first degree differential equation with variables separable. Just wait for a moment, my dear children. problem arised? Yes. Now come to this point. Second point. See here, this point. See this one. See this point, my dear children. Just wait for a moment. See here, this is the first question. In this exercise, we are going to solve the first order, first degree differential equation. Okay, my dear children, see here. Find the general solution of the differential equation dy by dx is equal to 1 minus cos x by 1 plus cos x. This is the given differential equation. It is a first order, first degree differential equation. In short form, we write it as capital letter D dot capital letter E. These two letters denote differential equation. Hereafter, please remember the full form of DE. The full form of DE. Okay. Now, this is a given differential equation. Dy by dx is equal to 1 minus cos x by 1 plus cos x. In this given differential equation, is there any function in y, my dear children? Is there any function in y? Is there any function in y? In LHS, dy by dx is there. In RHS, if you observe, this entire function is in the variable x. This entire function is in the variable x only. There is no function in the variable y. There is no function in the variable y. Yes or no? So, first let us simplify RHS by using trigonometric identity. This implies dy by dx is equal to, in the numerator 1 minus cos x is there, that can be written as 2 sin square x by 2 by, in the denominator 1 plus cos x is there, it is nothing but 2 cos square x by 2. Because we have a trigonometric identity, 1 plus cos a is equal to 2 cos square a by 2 and 1 minus cos a is equal to 2 sin square a by 2. By using these two trigonometric identities, we have written numerator and denominator. We have written numerator and denominator. Now, can you guess the next step? Numerator and denominator 2 is there. We can strike out numerator and denominator. Then dy by dx is equal to, what will you get here? Sin square x by 2 by cos square x by 2. Can it be written as tan square x by 2 or not? After cancellation,
Yes, sir.
after cancellation 2, we get sin square x by 2 by cos square x by 2. Can we write it as a tan square x by 2 or not?
Yes, sir.
So we have written as tan square x by 2. So here we got dy by dx is equal to tan square x by 2. This is equation 1. From this equation 1, we use separating the variables. Separating the variables means what I said, the entire function in the variable y into dy is equal to the entire function in the variable x into dx, means we have to send the denominator dx is there, the denominator dx is there. Let us send dx to RHS. Then can you tell me what is the next step? If you send dx to RHS, what will be the next step? Separating the variables. We are separating the variables. If you move dx, the denominator dx is there. If you move dx to RHS, can you tell me the next step? What will you get in LHS? This implies dy is equal to tan square x by 2 into dx. Yes or no? We have written the numerator dy as it is in the LHS is equal to, we transposed dx, that is in the denominator, we transposed dx to RHS. Then we got tan square x by 2. Understood this step, my children? Here we have separated the variables. We got an equation after separating the variables. Understood this equation too, my children? Understood this step or not?
Yes, sir.
After this step, we have to take integrals on both sides. Integrating on both sides of this equation 2. Integrating on both sides of this equation 2. So what will you get on integrating on both sides of this equation 2? We get integral dy. See there, in the previous step dy is there. We have taken integral. So integral dy is equal to, in RHS, tan square x by 2 dx is there. Just we have added integral sign. Just we have taken integral sign on both sides. That is called integrating both sides of the equation 2. Okay, my children? Understood this step? We are taking integrals on both sides. Now can you tell me what will you get in LHS? What is the value of integral dy? What is the value of integral dy?
Y, sir.
Yes, very good. Then what about integral tan square x by 2? What about integral tan square x by 2? Do you have any integral formula to evaluate integral tan square x by 2? Direct formula in any there? There is no direct formula. So we are rewriting the tan square x by 2 as secant square x by 2 minus 1 dx, because tan square theta is equal to secant square theta minus 1. We used that trigonometric identity. We have written tan square x by 2 as secant square x by 2 minus 1, because trigonometric identity tan square theta is equal to secant square theta minus 1. Okay, now we integrate the two terms in RHS. We have integrated LHS, so that implies y is equal to, integral secant square x by 2 dx minus integral 1 dx. Here there are two terms in this brackets, so we are integrating these two terms separately. Then can you tell me integral secant square theta dx, integral secant square x dx formula? Do you remember? What is the formula? Integral secant square of ax plus b, integral secant square of ax plus b dx. Tan of ax plus b by a, tan of ax plus b by a, and integral dx is equal to x only, because integral secant square of ax plus b dx is equal to tan of ax plus b whole divided by a plus c, and integral dx is equal to x plus c by using these two trigonometric identity integral, these two integral formulae. We wrote these two terms in RHS. Okay, secant square of this is a linear polynomial. If a linear polynomial is given, then we write like this. Remember this integral formulae. I have given this list also, this list of integral formulae at the beginning of this chapter. At the beginning of this chapter, I have given this formula also. Okay, I hope you have remembered that formula now. So here integration part is over. On both sides, integration part is over. Now we have to simplify the terms. In RHS, in the denominator 1 by 2 is there, we can write it as y is equal to 2 tan x by 2 minus x plus c. Simplification of the terms part is also over, and this is the last step. So we have added constant of integration, which is nothing but the solution of the given differential equation. Okay, my children, which is the solution of the given differential equation. These are the steps to be followed to solve a first order, first degree differential equation in the variables separable method. This is the first and foremost method. My dear children, you have to learn. Okay, my dear children. Understood these steps?
Yes, sir.
Can we go to the next question? Same steps.
Yes, sir.
Questions may differ, but we have to remember these steps, how to solve a first order, first degree differential equation by separating the variables method. Okay. Just wait for a moment, my children. Yes. See the question number 2. Question number 2. Find the general solution of the differential equation dy by dx is equal to square root of 4 minus y square, where minus 2 less than y less than 2. This is a given differential equation. Let us come to the solution part. What is the given differential equation? Hereafter I told you, capital letter D dot capital letter E stands for differential equation. This is a full form of D dot E dot. Is dy by dx is equal to square root of 4 minus y square. If you observe this given differential equation in the previous question, in the question number 1, in RHS, the complete function in the variable x, there is no function in the variable y. Whereas in this question number 2, can you find any function in the variable x? Can you find any function in the variable x in RHS? No, there is no function in the variable x. This entire function is in the variable y only. We are not given any function in the variable x. Understood this point, my children? Right. So directly we are separating the variables. Previously I told you we have to separate the variables. Here there is no function in the variable x. Directly we are writing the entire function in the y into dy is equal to the entire function in x into dx. Actually there is no function in the variable x, so simply we wrote dx. In this equation we have separated the variable. Understood this equation 2, my children? We have transposed square root of 4 minus y square to LHS, then it becomes denominator. Therefore we wrote dy by square root of 4 minus y square is equal to dx. We have transposed dx to the RHS. By transposing the terms to LHS as well as RHS, we are getting this equation 2. After getting equation 2, what will you do here? Integrating on both sides. After separating the variables, we have to integrate on both sides of this equation 2. Means we have to add integral sign on both sides. On both sides of the equation 2, we write integral sign at the beginning. So here we have written integral sign. See here, my children, integral dy by square root of 4 minus y square is equal to integral dx. Now we are going to find, we have to evaluate integrals on both sides of this equation separately. Then can you tell me how do you find integral dy by square root of 4 minus y square? How do you evaluate? Yes, here 4 is there, we can write 4 as 2 square. Yes or no? So integral dy by square root of 2 square minus y square is equal to, in RHS integral dx is there, in RHS integral dx is there. You know integral dx value is x, because integral dx is equal to x plus c. We are not writing constant of integration in this step. Previously also I told many times, we should add constant of integration at the last step only. Okay, now come to LHS. Can you find integral dy by square root of 2 square minus y square? Which integral formula is appropriate? Which is a suitable formula to evaluate this integral? Can you tell me? At least can you guess the appropriate integral formula to evaluate this integral? Any one of you? Integral dx by square root of a square minus x square. Integral dx by square root of a square minus x square, or integral 1 by root of a square minus x square dx. What is the formula? Integral dx by root of a square minus x square. Yes, sine inverse x by a. So sine inverse y, here variable is y, so sine inverse y by 2 is equal to x, because integral dx by, this is the appropriate integral formula to evaluate this integral. Integral dx by square root of a square minus x square is equal to sine inverse of x by a plus c. So on both sides integration part is completed. Yes or no, my children? Integration part is over. What should we do at the last step? We had to add constant of integration. So finally here we add constant of integration. That implies sine inverse of y by 2 is equal to x plus c. Finally we are adding the constant of integration. We can stop the solution by this step. We can write a conclusion step, which is the general solution of the given differential equation. Otherwise we can use inverse trigonometric properties here. Sine inverse of y by 2 is there. If you send sine inverse that side, RHS, what will you get? Can you tell me? Do you remember the inverse trigonometric properties? If you send sine inverse to RHS, then what will you get? This implies y by 2 is equal to sine of x plus c. Y by 2 is equal to sine of x plus c. Because sine inverse of x is equal to theta by implies x is equal to sine theta. Do you remember this inverse trigonometric property, my children? Sine inverse x is equal to theta by implies x is equal to sine theta. From this equation, you can write this equation. Similarly, here also we wrote this equation as y by 2 is equal to sine of x plus c. This is nothing but general solution of the given first order, first degree differential equation, which is the required solution, which is the required general solution of the given differential equation. Okay, my children, which is the
Yes, sir.
general solution of the given differential equation. So, on the whole, you have to remember 3 steps. You have to remember 3 steps. First step is you have to separate the variables like this, as in the equation 2. In the equation 2, we have separated the variables. And next step, we have to take the integrals on both sides. We have to take integrals on both sides. And we have to write the final step. That's all. Only 3 steps. 3 steps method to solve a differential equation. First order, first degree differential equation by using separating the variables method. Shall we discuss the next question? Shall we discuss the next question? Shall we go to the next
Yes, sir.
question? Yes. See the question number 3. See the question number 3. Find the general solution. Find the general solution of the differential equation dy by dx plus y is equal to 1, where y is not equal to 1. This is the condition. We cannot consider this part. We have to focus on this differential equation only. Dy by dx plus y is equal to 1. This is the given differential equation. We have to solve this first order, first degree differential equation. Okay, my children. Now come to the solution part. So, come to the solution part. Given differential equation. Given differential equation is dy by dx is equal to dy by dx plus y is equal to 1. This is a given differential equation. No need to focus on this part. Okay. Now, in this differential equation, can you find any function in the variable x? Can you find any function in the variable x? This is a notation dy by dx. This is not considered as a function in the variable x. This is notation dy by dx. This is a function in the variable y, and this is a function, constant function only. This is only a constant function. Can you find any function in the variable x in this differential equation, my children? Not at all. You cannot find a function in the variable x. So, first we transpose plus y to RHS. This implies dy by dx is equal to 1 minus y. We transposed the first y term to RHS, then we got dy by dx is equal to 1 minus y. Now this differential equation converted into the variables separable method. The given differential is converted into the variables separable method. How do you separate the variables? Previously I told you we had to write the entire function in y. In RHS this is called the entire function in y. We had to transpose we have to transpose this entire function in y to LHS, and we transpose by dx to RHS. Now can you tell me the next step? Can you tell me the next step? If you transpose 1 minus y to LHS, at the same time, if you transpose dx to RHS, what is the next step? Can you tell me, any one of you? What is the next step? How it become 1 minus y? How it become 1 minus y if you transpose 1 minus y to LHS? It becomes 1 by 1 minus y. It becomes 1 by 1 minus y, separating the variables. In this step, we are separating the variables. Separating the variables in the equation 1, we get dy by 1 minus y, dy by 1 minus y is equal to dx. In this equation 1, we separated the variables and we got this equation dy by 1 minus y dx. Okay, my children. Again, I am rewriting the function in LHS. This implies I have taken minus 1 as common factor from the denominator. Then we get minus dy by y minus y-1 is equal to dx. From the denominator, I have taken minus 1 common factor. Then we got like this. Now I transpose minus 1 to RHS. Then what will you get here? Dy by y-1. This implies dy by y-1 is equal to minus dx. Dy by y-1 is equal to minus dx. So we have separated the variables and we wrote as per our convenient. We wrote the equation as per our convenient. After that, we have to take integrals on both sides. We have to take integrals on both sides of this equation 2. That implies integrating on both sides of the equation 2. Integrating both sides of the equation 2, we get integral dy by y-1 is equal to minus integral dx. Understood this step, my children? On both sides, we have written integral sign. That's all. We have written integral sign on both sides at the beginning of the sides. So integral dy by y-1 is equal to minus integral dx. Now can you evaluate integrals separately in LHS as well as in RHS? What is the integral value? This one. Can you tell me? Which formula is appropriate to evaluate in LHS? It is in the form of integral dx by x. Dx by x. Since it is a linear function, linear polynomial, so we can use integral dx by x. That is log mod hello. Hello. Yes, good morning. Not now. Okay. Now, by using that formula, integral dx by x, integral dx by ax plus b, because it is a linear polynomial in the variable x. Integral dx by x plus b is equal to 1 by a log mod ax plus b plus c, and in RHS, integral dx is equal to x plus c. We used these two integral formula in LHS as well as in RHS. Okay, my children. After that, you can add constant of integration, because integration part is over. On both sides, you can add constant of integration, or sometimes in LHS there is a logarithmic function. So we can add log C in LHS also. We can add constant of integration in LHS as well as in RHS. As per our convenient, we can add. So here I am adding log C in LHS. It is also a constant. Log C is also a constant term. Okay, my children. Here log C, it is also a constant. Instead of adding C, we are adding log C. We can add this constant in LHS or in RHS as per our convenient. Here we have added log C in LHS because in LHS logarithmic function is there. That is why we have added log C. Now in LHS, if you observe these two terms are in the form of log A plus log B. What is the formula log A plus log B? Do you remember? Log A plus log B is equal to, yes, log AB. Log A plus log B is equal to log AB. So by using that logarithmic formula, we wrote LHS. Log C into mod y minus 1 is equal to minus x, because log A plus log B is equal to log AB. By using this logarithmic formula, we wrote LHS. After that, again use logarithmic and exponential functions property. Okay, my children. This implies we send this logarithmic function. We send this logarithmic function into RHS, then it becomes exponential function. If logarithmic function is transposed to RHS, it becomes an exponential function. So this implies C into mod y minus 1 is equal to e power minus x, because log y is equal to x. If an equation is given in this logarithmic function, we can write it as an exponential function as y is equal to e power x. Okay, my children, that's all. So finally we got this equation, which is nothing but the required general solution of the given differential equation. Okay, my children, which is the required general solution of the given differential equation. So this is the procedure to solve a first order, first degree differential equation by using separating the variables method. Okay, my children, understood these steps?
Yes, sir.
So you have to remember these steps, and accordingly you have to solve the differential equations. Okay, my children. Do the remaining sums. I will post this PPT in the Google Classroom, and I will show one more video. Fourth question will be there. Fourth question. Please wait for a moment. Please wait for a moment. Please wait for a moment. I will show the solution for one more question. Fourth question, I will show the solution for the question number 4 in this exercise. All of you wait for a moment, my dear children.
Children, this is a step. On both sides, I wrote the differential operator d by dx. Okay, my children, right? This implies d by dx of y can be denoted by y dash. Understood this y dash, my children? Right, is equal to
Yes, my dear children. Please watch the question number 6 solution also. Fourth question, not okay. Fourth and sixth question solutions. All of you watch the solution carefully.
question number 3. Please try the question number 3 yourself, my dear children. Follow the same steps throughout this exercise. The entire exercise is based on the same concept. Function will be given and differential equation is also will be given. We have to verify that the given function is a solution of the differential equation or not. Yes or no, children, we follow the same steps. Here also, come to the solution part. Y is equal to square root of 1 plus x square. Let us consider hello, my dear children. Welcome to the general solution of this differential equation. Right. Come to the solution part. Given dy by dx plus dx plus c minus secant square x equation secant square x tan y dx plus
Now watch the solution for the question number 4 and question number 11 also, my dear children. Please watch the question number 4 and question number 11 in this exercise solutions. Okay.
Okay, sir.
secant square y tan x dy is equal to 0. Okay, my children, understood this question? We have to find the general solution of this differential equation. Okay, my children, right. Come to the solution part. Let us write the given differential equation secant square x tan y dx plus secant square y tan x dx is equal to 0. Okay, my children, but this differential equation not, it is not in the form of dy by dx is equal to f of x comma y. Okay, my children, so first of all we have to convert this differential equation into that form. Dy by dx is equal to, in LHS there should be only dy by dx. Okay, my children, so for that let us move this term to that side, or they move this term to that side. Secant square y tan x dy is equal to, just I am transposing, I am moving this term to RHS. See, minus secant square x tan y dx. Understood this step, children? Just I transpose the term to RHS, then it becomes this. Then we get this step secant square y tan x dy is equal to minus secant square x tan y dx. Okay, my children, right. Now let us separate the variables. All the functions in y in LHS into dy is equal to the entire function in x into dx. In this way, let us separate the variables by separating the variables. By separating the variables, we get, what should we do here? In LHS, the entire function should be in y. So secant square y is there. Secant square y. In RHS, there is tan y. So transpose the tan y to LHS. Then it becomes by tan y. Okay, my children, understood this point? Into dy. There is no function in y. Then the function in y is moved to LHS. Then it becomes 1 by tan y. Then we got secant square y by tan y is equal to dy. Similarly, here tan x is there in the LHS. We transpose that tan x to RHS. So minus secant square x by tan x into dx. Understood this step, children? In this step, we have separated the variables so that the entire function in y into dy is equal to the entire function in x into dx. Okay, my children. So this equation is comfortable to us to integrate. Okay, my children. Now integrating, after separating the variables like this, in the integrating on both sides. Integrating on both sides. Then we get integral secant square y by tan y dy is equal to minus integral secant square x by tan x dx. Okay, my children? Right. Now it is in the form of, understood this step, my children? Right. Now it is in the form of integral f dash x by f of x. If you Consider f of y as f of x. Then its derivative is tan y, derivative is secant square y. As are my children, d by dx of tan x, secant square x. So it is in the form of integral f dash x by f of x. Then what is the formula? Log mod f of x. So log mod tan y is equal to minus, here also we use the same integral formula, log mod tan x. Tan x. Okay, my children, because integral f dash of x by f of x dx is equal to log mod f of x. Okay, my children, understood this step? Right. Now let us transpose this term to LHS. Then it becomes log mod tan y plus log mod tan x. Okay, my children, is equal to 0. Okay, my children, understood this step? Right. Or you can write plus is equal to c, some constant. We are adding some constant here. Okay, my children, understood this step? Right. This can be written as log mod tan x into tan y is equal to c, because log a plus log b is equal to log of ab. Yes or no, my children? By using this logarithmic property, I wrote this LHS part is equal to c. Okay, my children, understood this step? Then this implies tan x into tan y is equal to e power c, because log a base c is equal to x implies e power x is equal to a. By using this logarithmic property, I wrote this step. Understood this step, my dear children? Right. Which is the required general solution, or you can write as a c also. E power c, it is also a constant. Okay, my dear children. So tan x into tan y is equal to c, where e power c is equal to c, some constant. It is also some constant. So we can write any other constant is equal to c, which is the required general solution. Which is the required general solution of the given differential equation. Understood this point, my children? Right. Here I am not explaining the question number 5, question number 6, question number 7, question number 8, question number 9 and question number 10, because all these questions are of the same type, finding the general solutions of the differential equations. Okay, my children. So I am leaving these questions to you. Please try these questions yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Now the second part of this exercise. Second part. What is this second part? Find the particular solution. Find the particular solution of the differential equation x cube plus x square plus x plus 1 into dy by dx is equal to 2x square plus x. Y is equal to 1 when x is equal to 0. Okay, my dear children. Here also, what is the question here? We have to find particular solution. In the previous questions, we have found general solutions of the differential equations. Now we have to find particular solutions of the differential equation. Particular solution of the given differential equation when y is equal to 1 and when x is equal to 0. This is just a little bit extension to the previous method. Means first of all, here also we had to find general solution of this differential equation. First of all, we have to find the general solution of this given differential equation. In that general solution of the given differential equation, we have to substitute y is equal to 1 and x is equal to 0. Then we get the value of c. In the previous problems, we did not get the constant of integration, the value of constant of integration. Yes or no, my children? In this case here, we get the value of c. That is only the difference between general solution of the differential equation and particular solution of the differential equation. Okay, my children, understood the difference? Right. Come to the solution part. Given x cube plus x square plus x plus 1 into dy by dx is equal to 2x.
Okay, my children, I will post this video in the Google Classroom. Please watch the video. Still 20 minutes are there in the video. 20 more minutes are there. Please watch that remaining part of this video also. Okay. After that, do the remaining sums in the exercise. You have to follow the same procedure, nothing difference. Okay, my children. Will you do that?
Okay, sir.
Will you do the remaining sums in this exercise by following the same procedures? If you have any doubts, ask your doubts and get your doubts clarified, but don't skip. Don't escape in doing your work. Be sincere and serious in your studies. Okay, my children? Right.